Hello, it's Joni Rotten. I have an article I want to share. This one comes to us from the National Library of Medicine, National Center for Biotechnical or Technology Information. This is environmental pollutant. It's published in 2021, January 30th, it looks like. It says associations of exposure to, and I can't say that word, but that's PFAS substance, individually and in mixtures with, what is this? Persistent infections. This is the recent findings from 1999 through 2016. This is very interesting. I won't be able to read a lot of this because it's going to be very complicated, but let me just hit all of the high points. Certain viruses and parasites can cause persistent infections that often co-occur and have been associated with substantial morbidity and mortality. Separate lines of research indicate exposures to PER and PFAS suppress the immune system. We hypothesized that PFAS exposure might systematically increase susceptibility to persistent infections, resulting in a higher pathogen burden. And I can't help but be reminded of all the times Gates has said, one of these days we're going to have a major event in a virus. And when we're pumping our systems with PFAS, it's kind of easy to see where he thought this idea might come from. So they used the data from 8,778 individuals, 3,189 were adolescents, 5,589 were adults. In the nationally representative U.S. National Health and Nutrition Examination Survey from 1999 to 2016 to examine cross-sectional associations between serum concentrations of 4 highly detected PFAS, and that's PFOS, PFOA, HXS, and PFNA, with the presence of antibiotics to cytomegalovirus, Epstein-Barr virus, hepatitis C and E, herpes simplex 1 and 2, HIV, T. gondii, and Toxocara spp. Seropositivity was summoned to calculate a pathogen burden score reflecting the total number of infections. Separate survey-weighted multivariable regression models were fitted to analyze PFAS individually, and quantile G computation was used to analyze PFAS mixtures. And so then it goes on to have some of the statistics, and here you can see they had a seropositivity. In other words, they tested positive for these antibodies, cytomegalovirus, Epstein-Barr virus, hepatitis C, D, E, herpes simplex 1 and 2, HIV, toxoplasmosis gondii, and Toxocara spp. And we've talked about so many of these things, so these should be very familiar names. And here is the compounds of the biomarkers for PFAS. Here's your population, and of course the difference between adolescents and adults. It says using nationally representative National Health and Nutritional Examination Survey from 1999 to 2016 data, we found that the PFAS are associated with a higher burden of persistent infections. This finding was consistent for both individual PFAS and PFAS mixtures, with adolescents appearing particularly susceptible. So the background says that PFAS are a class of synthetic chemicals that contain an alkyl chain with at least one fully fluorinated carbon atom. They have been manufactured and used in many industries since the 1940s. More than 4,700 PFAS exist and are commonly found in consumer products such as nonstick cookware, stain repellents, waxes, paints, and cleaning products. And it names a bunch of other things I'm not going to pronounce. You can find a link in the description. They are the most extensively produced and studied of the chemicals, and a couple are no longer manufactured in the U.S. due to the phase out of these chemicals by the Environmental Protection Agency in 2009, but are still produced internationally and imported. That's important to know, so we get a lot of stuff from China. Recently, extensive biomonitoring and another thing I want to state is when they stop using one, they basically just change the name. So it's a tiny bit off, but it is still just as dangerous, and has basically the same compound, which you can see here in the pictures of what they look like. So there's just maybe one little thing, but it's all the same stuff. So when they say we get rid of one, they're just replacing it with another number, another PFO, Q, and so forth and so on. So it says that recently extensive biomonitoring by the U.S. National Health and blah, 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 has detected these compounds in the blood of more than 98% of Americans. And we should note that Epstein-Barr virus is in 95% of the worldwide. Now, I imagine this 98% is not just Americans, but everywhere. So these are things to keep in mind. Such widespread human exposures, along with long clearance half-lives and persistence in the environment, have made PFAS a concerning and actively researched class of environmental contaminants. Basically, what this is going to say is that your viruses are coming up. This ruins the human immune system. This is a killer. And our consistent interaction with these things is causing our immune system to not be working properly. So when we have things like a flu season, are we possibly poisoned in a way? Existing literature surrounding the health effects of PFAS indicates that exposure can result in numerous health consequences, such as reduced fertility, which we're seeing a lot of preeclampsia, birth defects, liver damage, thyroid disease, and of course our favorite C word, cancer. Importantly, a number of studies have reported PFAS-associated immunotoxicity in both humans and animals. A systematic review by the U.S. National Toxicology Program concluded that both PFOS and PFOA are hazards to the human immune system based on a high level of evidence from animal studies and a moderate level of evidence from epidemiological investigations. In these studies, PFAS immunotoxicity primarily manifested as suppression of immune responses. We have summarized the existing epidemiological literature on PFAS immunosuppression. Wow, my tongue is really getting a workout. Previous let's just say, I think you get the idea. It has been associated with lower concentrations of vaccine-induced diphtheria, tetanus, sorry. I'm not a doctor, right? Don't see that word every day. Is that tetanus? And rubella antibodies in childhood. That's your MMR, measles, mumps, and rubella. Exposures to certain PFAS have also been inversely associated with vaccine-induced rubella, mumps, and the influenza antibodies. These findings generally indicate that PFAS exposures suppress the and they render the vaccines less effective. That's interesting to know. So here's some more charts and things, as you can see, where it has done these things. And of course, you know, it's age. That's another interesting thing there. So let's go down to, let's skip all of this. You can definitely see what they're getting at here. I would encourage anyone who questions anything that's going on in the world. So if you're seeing something and you're going, type it into Google and write linked to EBV or Epstein-Barr, and you're going to find so many interesting things here linked to these viruses. This is all some Fauci category, some Gates, you know, real estate here. We also considered the role of certain lifestyle factors, for example, tobacco smoke exposure, household crowding, and body mass index, and associations of PFAS exposures with infections. Previous research established tobacco smoke exposure increases the susceptibility to infectious disease. As a marker of tobacco smoke exposure, we use serum concentrations of, I don't know how to say that word, cotinine, a major metabolite of nicotine, to incorporate both active and passive smoking smoke exposures. Living in a crowded house increases the risk of exposures to pathogens. Therefore, we calculated a household crowding index by dividing the reported number of people that reside in the household by the number of rooms. And it has been suggested that PFAS are endocrine disruptors, and exposures have been shown to promote weight gain. Since the literature also suggests being underweight or obese as risk factors for infection, we conceptualized BMI as a mediator. BMI was calculated from example. And some other things that they've done. Let's kind of skate down here to the results if we want. The descriptive statistics, population characteristics, and geometric mean concentrations of the 4 PFAS measured in serum are presented in this table. The population was about half female and mostly non-Hispanic white. Socioeconomic status was varied, with approximately 1/3 of individuals reporting a family income of less than 1.3 times that of the appropriate federal poverty threshold, and another 1/3 reporting a family income of more than 3.5 times that amount. And they had adolescents and adults, and the majority had serum cotinine concentrations below 1 ng/ml, indicative of no tobacco smoke exposure. Among adolescents, about 1/3 were classified as overweight or obese, while among adults, about 2/3 were overweight or obese. And one of the 4 PFAS, PFOS was the most abundant in serum samples, followed by PFOA, PFH, XS, and PFNA. For all PFAS, adults tended to have higher concentrations than adolescents. As shown, the most common infection among adolescents was Epstein-Barr virus. They had about 72.6 seropositive, while the most common infection among adults was herpes simplex virus 1, with 56.8% being seropositive. Seropositive means that they have a buildup of the antibodies. Distribution of summoned seropositivity or pathogen burden are provided. Among adolescents, 38.7 were infected by only 1 persistent pathogen, 14.9 were co-infected by 2 or more persistent pathogens, and adults had 48% infected by 1, where they had 19.7 co-infected by 2 or more. There's more models. Excuse me. I'd mute, but I'd have to click a bunch of buttons. So you're just going to have to listen to me cough. It's early. So here in this discussion, let me see if that's the conclusion. Yeah, okay, we'll do the discussion and then the conclusion. In this cross-sectional study, we analyzed associations of PFAS exposure with several persistent infections and pathogen burden in a nationally representative sample of adolescents and adults. We found that serum PFAS concentrations individually and as mixtures were associated with a higher burden of persistent infection. These associations were independent of differences in sociodemographic characteristics and lifestyle factors, including body mass index, which we hypothesized as a mediator, indicating PFAS exposure may increase susceptibility to persistent infections through mechanisms other than changes in weight. Among the 4 PFAS we evaluated, PFOS and PFOA were the most strongly tied to higher pathogen burdens, a finding that was consistent across traditional single PFAS regression models and novel quantile G computation. Both of these substances have largely been phased out of production in the US, but they remain in circulation from imported goods such as carpet, textiles, furniture, automobile parts, electronics, and household appliances, and persist in the environment. PFAS accumulate in the human body over time, and indeed, we found adults tended to have higher serum concentrations than adolescents. Despite this, we consistently observed strong associations in adolescents as compared to adults, suggesting adolescents may be uniquely susceptible to adverse effects of PFAS exposures on the immune system. What I find interesting about that is adolescents are doing what? They're developing, they're going through a puberty stage where their body is making drastic changes. It's literally the only time in our lives that these massive changes are out for the public to see. PFAS exposures have been studied with respect to human immune function, although most epidemiologic investigations have focused on antibody-mediated immunity. Data from animal studies, however, suggest PFAS exposure also suppress non-specific immune responses. For example, mice exposed to PFOS have been shown to have damaged gastrointestinal tract barriers. PFAS is often ingested via contaminated food and water, and certain persistent pathogens, for example, hepatitis E virus, Toxocara spp, Toxoplasma gondii, are also commonly ingested, making the gastrointestinal tract a plausible mechanistic target. Other animals have shown PFOS reduces natural killer cell activities. PFOA decreases neutrophil migration responses, and PFOS and PFOA both lower macrophage counts. These cell types are responsible for killing virally infected cells and engulfing and destroying parasites, and as such, impaired functionality and deficient quantities can increase susceptibility to infectious disease. The result of this study demonstrated PFOS and PFOA were associated with higher pathogen burdens across individuals aged 12 to 49 years, but suggest adolescents may be particularly at risk. One possible explanation for this finding is the immaturity of the adolescent innate immune response. I think, too, let's keep in mind that mononucleosis, often called the kissing disease, is a very prevalent adolescent infection. Many reasons why. You can see that. There are several aspects of innate immunity that increase with age and do not develop fully until adulthood. For instance, the gastrointestinal wall increases in thickness by about 20 to 40, whatever that is there, annually. Here's the thing. From birth until age 20, forming a first line of defense against pathogens. Circulating cells of the innate immune system also exhibit qualitative and quantitative differences with age. One such example is neutrophilic leukocytes, which are the first cells to migrate from the bloodstream to infected sites and can eliminate many pathogens via phagocytosis, I'm not sure how to say that. Neutrophil proportions increase linearly with age to become the predominant leukocyte subtype in adulthood. And the capability of neutrophils to migrate to infected tissue also matures with age, with adolescents reaching adult levels of this around the age of 15. Therefore, differences in innate immune function between adolescents and adults may explain heterogeneous associations of PFAS exposures with pathogen burdens and are worthy of future study. Persistent pathogens establish chronic infections, and some are never fully cleared from the human body. Due to their lack of acute health infections, many persistent pathogens have been understudied. However, recent research has begun to suggest links between infection with these pathogens and chronic disease. For example, cytomegalovirus and herpes simplex virus type 1 have each been associated with cardiovascular disease, whereas Toxoplasma gondii, that's the crazy cat lady, has been associated with impaired memory. Simultaneous infections with multiple persistent pathogens, the pathogen burden, may have even more relevance for long-term health, with several studies identifying cumulative health effects beyond those of infections by a single pathogen. By systematically evaluating individual pathogens and total pathogen burden, our study contributes to our understanding of whether PFAS exposures modulate susceptibility to and foster the clustering of persistent infections. There are notable limitations to the present study. Foremost is the cross-sectional nature of the data. Remember, that's that long term. Although the PFOS and PFOA have long half-lives in humans, estimated to be approximately 5 years, without prospective data, we have no way of knowing whether exposure preceded initial infections. An additional concern is outcome misclassification. In response to cytomegalovirus, Epstein-Barr virus, herpes simplex virus 1 and 2, hepatitis virus types C and E, human, that's HIV, T. gondii, and Toxocara, the IgG is produced within the first few months following primary infection and generally persists for life. Without additional serological data, it is possible that some very recent acquired infections were missed in our analysis, although we expect this number to be small. At the same time, it is possible that some symptomatic cases were also excluded, especially any cases who were hospitalized, thus precluding the eligibility. While this scenario may have introduced bias, we expect the influence to be minimal, given that the majority of the infections we examine tend to manifest without symptoms. Another limitation was that we only investigated 4 legacy PFAS, Interestingly, time stratified analysis revealed positive associations with adolescent pathogen burden only within these years, when the serum concentrations were markedly lower than in earlier years. It is possible that differences in association over time are due to residual confounding by newer replacement PFAS, such as Gen X. And stay tuned, as I will be diving into that and some of its debacle, for which high quality biomonitoring data were available. That's why. Finally, a lack of data on long-term diet, a strong contributor to PFAS exposure, meant we could only assess how PFAS exposures were directly related to persistent infections without capturing indirect effects mediated by body composition. Therefore, the total effect of PFAS exposures on pathogen burden may be even larger than we were able to establish. We were, however, able to account for several other determinants of PFAS exposures that may have confounded associations, and we're also able to address confounding by PFAS co-exposures through quantile G computation. The consistency of results from this novel statistical method with our traditional multivariable models strengthens the internal validity of our findings. And other important strengths of our study include its large sample size, inclusion of a study sample representative of the non-institutionalized civilian U.S. population, and use of objective biomarkers of PFAS exposure. So in conclusion, in summary, we are the first to evaluate environmental PFAS exposures in relation to persistent infections. We observed higher exposures to PFOS and PFOA were associated with higher number of infections or pathogen burden, a composite measure that appears to increase the risk for subsequent chronic disease and mortality. While confirmation of our findings with prospective data is necessary, lowering exposures to PFAS exposures, particularly during youth, may decrease infectious disease susceptibility and long-term consequences of persistent infections. In other words, stop poisoning the children. So that is that. It was funded by the National Institute of Environmental Health Services. The authors declare that they have no competing financial interests or personal relationships that could have appeared to influence the work. Anyway, here are some links. You can also go and read through some of the other things in which they've got this information. And thank you for listening to me struggle through this article, it's a research paper, not technically an article, but I think this is important. We're talking about a pandemic, right? We're talking about an end of the world scenario. We have tons of toxic chemicals and substances that we are ingesting, breathing, drinking, soaking in our skin through lotions and makeups and all of these things. And they quite possibly could be, according to this, contributing to the illnesses everyone is experiencing, especially when it's my belief, but you don't have to believe me, that they're man-made illnesses in some cases, or at least possibly, or if not today, they will be in the future. If I know the mechanisms, then I know how to make the virus exactly to my liking. They also act like this is the first they've ever heard of these things when they come out with these articles, and yet we all know HIV is a long-studied virus, so you've got to assume that they know a lot. And they say things like, we're just now studying cytomegalovirus. We're just now breaking apart Epstein-Barr virus. That's not true. That's actually not true. They've had the Epstein-Barr virus DNA broke down since 1984. So that's going to do it for this rotten read. I hope you found that somewhat interesting. There is a lot more. I'll continue to read and share as I go along. Watch the window.